You're sitting in a stuffy office, dead silence all around, and suddenly your body does it. That sharp, stupid, loud jolt in your chest that cuts you off mid-sentence. You hiccup. Everyone turns around. Your face instantly flushes, and your hand frantically reaches for a glass of water. In that moment, you think you just inhaled a dry sandwich too fast. But reality is way weirder. Right now, in seconds, your brain just rewired your respiratory system for the needs of a creature that crawled out of the ocean 370 million years ago. Your body decided you grew gills. And it tried to save you from drowning in water that isn't even there. Why did evolution keep this ridiculous glitch? To get to the bottom of it, we'll have to untangle a 14-inch wire in your chest, meet a guy who hiccuped for almost his entire life, and dive into the mind of a tadpole. If you've ever tried to cure hiccups by holding your breath until you turned blue, hit that like button. It helps the channel. And let's start our deep dive. But before we head down to the fish, answer one question. Why does this bizarre gill reflex kick in for babies in the womb before they ever take their first real breath? The answer shatters everything we thought we knew about preparing for life. We tend to blame hiccups on dry food or cold soda. You're sitting at a table, take a quick gulp of ice water, and something inside just snaps, like an invisible trap. A spasm knocks the air out of you. Your throat clamps up. You make that ridiculous sound. People around you cheerfully say someone must be thinking of you. Or they whip out the classic home remedy torture kit. Drink from the far side of the glass while bent over. Hold your breath until you're blue. Scare you half to death. The funny part? Sometimes it actually works. But the physiology behind this miracle is far from magic. When your well-meaning friend pops a plastic bag right by your ear, your nervous system gets a shock. Your heart pounds. Your brain switches into survival mode. In that instant, it just ditches small peripheral processes to save you from an imaginary predator. A temporary system glitch gets overridden by a stronger danger signal. You go quiet. The hiccups fade. If you try drinking water while twisted into some awkward pose, you're mechanically forcing your swallowing muscles into an unfamiliar rhythm. That irritates the receptors in your throat. The vagus nerve, which had been sending panic signals to your brain, suddenly gets distracted by the complex task of drinking upside down. The program resets. The spasm stops. But it's just a temporary patch on a system error. The real story is that your stomach and esophagus are trying to handle physical pressure. Our habit of eating on the run, chugging liters of carbonated gas from soda, and gulping air along with pizza slices turns your stomach into an overinflated balloon. It stretches out. It gets too cramped inside your body, and it starts pressing on a neighbor that really doesn't appreciate the intrusion. And that neighbor knows how to get payback. This touchy neighbor is called the phrenic nerve, and its anatomy is an engineer's nightmare. Imagine you have to run a wire from a control button to a motor. The logical thing would be to make it as short as possible, but evolution took a different route. In your body, this nerve starts up in the neck, passing through spinal segments C3, C4, and C5. From there, it snakes all the way down through your entire chest cavity, literally loops around your heart, and only then reaches the dome of the diaphragm. That whole path is about 35 centimeters long. It's absurd. In our distant ancestors, the fish, the breathing muscles were right at the base of the head, right next to the gills. That nerve was less than a centimeter long. The signal arrived instantly. But when our ancestors crawled onto land and started developing necks, their breathing apparatus gradually migrated deeper and deeper into the chest cavity. No one bothered to rewire the thing. The nerve just obediently stretched out as the organ slid downward. Now this long, unprotected cable runs dangerously close to your esophagus and stomach. Any mechanical irritation along that lengthy route causes a short circuit. When you swallow too big a chunk of poorly chewed food, it basically squeezes through your esophagus. The tissues expand and brush against the vagus nerve. A chain reaction kicks off. An alarm signal shoots up to your brainstem. The brain panics, decides to reboot the respiratory system, and fires a sharp impulse back down that same 35-centimeter cable to the diaphragm. the diaphragm spasms. You take a sudden, powerful inhale. But in that same millisecond, your larynx realizes that a piece of food might fly into your lungs. The glottis snaps shut instantly. The airflow slams into the closed vocal cords at full speed. It's a genuine hydraulic shock. The whole process takes just 35 milliseconds. That's 3 times faster than you can blink. Your body literally slams its own brakes at full speed. And in that moment, an ancient ghost that's been sleeping in your head for millions of years wakes up. This ghost comes from a time when our ancestors hadn't quite decided whether they wanted to live on land or stay in a warm swamp. About 370 million years ago, strange creatures crawled around the planet, the ancestors of modern amphibians. They had both lungs and gills. A typical example of this dual nature today is the common frog tadpole. To breathe underwater, it has to pump water through its gills. But if water gets into its developing lungs, it simply dies. So how do you solve that problem? Nature came up with a harsh but reliable solution. The tadpole takes a sharp inhale with its gill muscles, sucking in a mouthful of water. But a fraction of a second later, a special valve at the entrance to the lungs snaps shut. The water gets directed to the gills. Lungs are saved. The system works perfectly. Does any of this sound familiar? Yes, that's your hiccup. The sharp contraction of the human diaphragm is an exact copy of the tadpole's inhale that pumps water through its throat. And the instant snapping shut of the glottis with that characteristic hic sound, that's the work of that same protective valve. Your body is literally trying to breathe through gills that you lost long ago. In the early 2000s, a group of neuroscientists compared the neural firing patterns of tadpole breathing with mammalian hiccups. The results caught them off guard. The two processes turned out to be almost identical. The generator for this rhythm lives in the oldest part of your brain, the brainstem. You can control your thoughts. You can hold your breath on purpose. But you have zero power over that ancient relic. The moment your vagus nerve sends a signal about some trouble in your gut, that old fish program wakes up. Your brain obediently runs the ancient algorithm. It tries to flush water through your throat. But why didn't evolution just delete that junk code from our DNA over millions of years? Simple answer. Nature never rewrites programs from scratch. It just adds new floors on top of an old, shaky foundation. It was way easier to slap a block on that reflex using the newer cortex than it was to completely rebuild the brainstem's architecture. Your brain is constantly keeping a finger on the button that suppresses gill breathing, but sometimes that finger slips, and then the ancient software boots up again. Sometimes that slipping finger breaks a person's life. In 1922, a young American named Charles Osborne fell while weighing a pig. He got up, felt fine, but immediately started hiccuping, and he couldn't stop. His hiccups lasted for the next 68 years. They stopped on their own a year before he died, when Charles was 96. By then, he'd hiccuped roughly 430 million times. And despite that, he managed to live a normal life, work, and even raise kids. Doctors couldn't figure out what caused it for a long time. Only later did they discover that when Osborne fell, a tiny blood vessel in his brainstem burst. The microscopic area that's supposed to hold back that ancient gill reflex had been damaged. The brakes just failed. The program went into an infinite loop. A normal bout of hiccups lasts a few minutes, but if it sticks around for more than 2 days, that's a serious reason to see a doctor. In medical cases, chronic hiccups often point to damage in the vagus or phrenic nerve. It could be a tumor in the chest pressing on the wiring, the aftermath of a stroke, or the onset of multiple sclerosis. That ancient program only kicks in when the pathways controlling it get destroyed. Your inner tadpole breaks loose the moment you lose control. But honestly, most of the time we wake that sleeping beast ourselves with the way we live. Fast food, fizzy drinks packed with carbon dioxide, ice-cold water on a hot day, spicy sauces that irritate your esophagus, all perfect triggers. We eat too fast, practically gulping down air along with our food. The stomach blows up instantly and starts pressing on the phrenic nerve. The wire shorts out. The system throws an error. By the way, drop a comment and tell us how long your worst hiccup attack lasted, minutes or hours, and what trick actually worked for you. It'll be interesting to compare notes. And while you're typing, let's figure out why this useless glitch actually made deep sense for our survival way back at the beginning. And that brings us right back to the question we started with. Why do babies in the womb start hiccuping intensely long before they take their first real breath of air? It turns out that for an unborn infant, this ancient reflex is a matter of survival.
In the early stages of development, the fetal lungs aren't ready to breathe yet. They're filled with amniotic fluid. If the baby took a normal breath, that fluid would rush in and damage the immature alveoli. That's where the tadpole program comes to the rescue. A sharp spasm of the diaphragm stimulates the development of the respiratory muscles, preparing them for future life on land. But at the same time, the instantly closing vocal cords lock the airways shut. Fluid simply can't get into the lungs. For the embryo, this is the perfect training tool. It works the chest muscles while keeping the lungs securely sealed. So it turns out that every one of us survived in the womb thanks to that ancient fish software. But when we're born and take our first breath of air, this system becomes completely unnecessary. The brain builds new neural pathways, takes conscious control of breathing via the cortex, and puts a reliable safety catch on the gill reflex. We grow up. We become adults, build cities, and write books. But that old safety catch in our brainstem wears out over time, and sometimes it malfunctions. Next time your body suddenly lets out that ridiculous sound in the middle of an important meeting or a date, don't rush to get mad at yourself. And don't frantically try to drink water while bending over double in front of your surprised colleagues. Just listen to that rhythm. It's not a glitch in your system. It's your inner tadpole sending you a greeting from the primordial ocean across 370 million years of evolution. Your body isn't a perfect blueprint from some standards bureau. It's a living museum where every strange reflex and silly quirk carefully preserves the story of your origins. And now you know that story. If you found it interesting to dig into the inner workings of your own body, hit subscribe. Here we regularly dissect everyday life with science. Take care of your vagus nerve, and I'll see you in the next deep dive.